This video continues with our discussion of proofs in SL. Specifically, we're going to introduce the conditional elimination and biconditional elimination rules. As a reminder, remember that a proof has this kind of structure. We number every line, we put the premises at the beginning with a horizontal line underneath them, and every line after that has to be justified by a rule. There are 11 basic rules of proof in the proof system for SL. Reiteration, plus an introduction and an elimination rule for each connective. We introduced 3 of the rules in the previous video, and in this video we'll introduce 2 more. Let's think about what the conditional or arrow elimination rule should be. Suppose you know S arrow T. What can you conclude? Think about that for a moment. S arrow T only tells us that if S, then T. It doesn't tell you anything about S and T on their own. So just from line 1, there's nothing we can conclude. But suppose you also knew S. Well, then you'd be able to conclude T. So the conditional elimination rule requires 2 lines. Here we have the conditional on line 1, and we have the antecedent of the conditional on line 2. So we can write down the consequent of the conditional, justification, conditional elimination, 1, 2. This is what the schematic version of the rule looks like on the reference sheet. It has M and N instead of specific numbers because they might be any lines of the proof. They might have occurred in separate places much earlier. And it has a script A and a script B because they might be long compound subsentences. The important point is that conditional elimination requires 2 lines. We have to have the conditional and we have to have the antecedent of the conditional, and it lets us write down the consequent. You might remember this from an earlier video when we used its historical Latin name, modus ponens. Here we call it conditional elimination because that fits it into the structure of our basic rules. Suppose we have this problem. Show, given A arrow B, B arrow C, and D and A, that you can prove C. Recall that symbol means that a proof is possible. Given those 3 sentences, we can give a proof of the right-hand sentence. We set the problem up in the usual way, writing the 3 premises down first. And I've scribbled in a note, want C. It's not actually part of the proof, but it's a note to ourselves that the proof needs to end with C. We look at the 3 premises and ask, what can we do with these? If you look at line 1 and line 2, the only rule we have that applies to conditionals is conditional elimination. We can't use conditional elimination, or at least not yet, because using conditional elimination on line 1 would require that we also have the antecedent somewhere else in the proof. To get rid of A arrow B, we'd have to have A on its own line. To get rid of B arrow C, we'd have to have B on its own line. And we don't have those yet. So we can't do anything yet with line 1. But look at line 3. Can we do anything with that? Well, D and A, it's a conjunction, an and the and elimination rule just requires the 1 line. We can write down A, and elimination applied to line 3. And notice now this has given us A on its own line. So we can now use conditional elimination to write down B. Importantly, this is applied to line 1 and 4. So we had to have line 4 before we could have line 5, where we get B from the conditional and from the antecedent. Since we have B on its own line, we can now use the conditional on line 2, along with the left-hand side of it, the antecedent on line 5, to get C. So conditional elimination on 2 and 5 gives us C. C is what we wanted, so we're done. The rules give you permission to write things down, so there are always options. Suppose you'd looked at the beginning of the proof, decided to apply and elimination to line 3, but done it this way. You wrote down D and elimination applied to 3. This follows the rule, so it's not wrong. It's not obviously helpful, though. What next? D doesn't really get you anywhere. If you realize this, you might erase it and start over, but you don't have to. Line 4 follows a rule, and so it's a totally legitimate step in a proof. Maybe you notice that you can also write down A from line 3 and elimination. And again, this follows the rules. And maybe you finish out the proof just in the way we did earlier. If you compare this to the earlier proof, the line numbers have changed a bit because there was that extra line 4 where we inferred and wrote down D, and then everything else is shifted down one step. But this proof does what's asked just as much as the earlier proof did. It has an extra line. Line 4 isn't doing any work, but it's still a correct answer. And so an important thing to note, once we're doing proofs, you might end up with different answers than somebody else, but provided you follow the rules at every step along the way, and you end with the conclusion, it's as good an answer as any. Now consider the biconditional. Suppose you have S if and only if T. You can't conclude anything from this alone. If you knew S, though, you could conclude T. This is the only if direction of if and only if. But if you knew T, you can conclude S. That's the if direction. So the biconditional elimination rule, double-headed arrow E, is like arrow E, like the conditional elimination rule, except that it works in both directions. And because it works in both directions, it has 2 versions on the reference sheet. You now have 2 more of the basic rules. Next, we'll introduce the rules for disjunction.